Hello, I'm going to talk to you about the coordinate plane and solutions to linear equations in standard form. We'll begin with the coordinate plane or the Cartesian plane. There are two lines that intersect perpendicularly. You have the vertical line and the horizontal line, and these form a 90-degree angle perpendicular. The horizontal line is the x-axis, the vertical line is the y-axis. Where they intersect is called the origin. Right there, where they intersect is called the origin. The coordinate for the origin is 0, 0. The x and y axes can simply be viewed as number lines. In the direction of right, so moving to the right, is positive. In the direction for the x-axis, in the direction of moving, and we'll say up, but in the direction of moving up is positive for the y-axis. In the direction of moving to the left along the x-axis is negative, and in the direction of moving down along the y-axis is negative. So to the right and up is positive, and to the left and down is negative in directions. Coordinates or ordered pairs. Coordinates or ordered pairs are written as x comma y. X comma y. The axes, when drawn together and intersect, form four coordinates or quadrants. They form four quadrants. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. Each quadrant has a set of characteristics, just like with our axes. And that's where they get their characteristics from, is where they're located in conjunction with the axes. Quadrant 1 has x values that are positive and y values that are positive. And you can look at that. From 0 moving to the right are positive values. From 0 moving up are positive values. That's why positive and positive. Quadrant 2 has the characteristics of x values being negative and y values being positive, which this should make sense. This is 0. Now I'm moving to the left. And again, remember, treat these like number lines. So I'm moving to the left, I'm moving toward negative. So that's why the x values are negative. Here's 0, and I'm moving up. My y values are positive. In quadrant 3, the x values and the y values are both negative. And think about that. Moving to the left and moving down. And in quadrant 4, x values are positive because I'm moving to the right from 0. And then the y value is negative because I am moving down from 0. So, characteristics for each quadrant. This is good to be able to critically think about where your coordinate is supposed to be before you ever plot it. Good check for you once you get your coordinate written down. Does that make sense? Are my signs correct for my x and y value? Okay, so what I would like to do is I would like to, we have to practice what we talk about. So together we're going to graph 2 comma 1. And how we do that is we start at the origin, and remember, this is x and this is y. So I'm going to start at the coordinate or at the origin, and I'm going to deal with the x portion of the ordered pair. I'm going to move 2 units in the positive direction. I have no numbers written down here on my number line, and I didn't write them because it would be too busy having all of this written here. Each tick mark represents 1 unit. So I will move 2 to the right in the positive direction. 1, 2. So this is where I'm now at on the x-axis. I'm at 2 units. Next, I look at my y value. My y value is a plus 1. So that means I'm going to move up 1 unit. So from here I move up 1 unit. And that is my coordinate 2 comma 1. Okay, Pause the video, get an understanding of where these two are going to end up being graphed, or graph them out yourself. Alright, so next one we're going to graph is a -3, 4. Before we do that, I'm going to look at this in the characteristics. My x is negative and my y is positive. What quadrant would that be in? Negative x, positive y. Excellent. Second quadrant. So that's my checking mechanism. So I'm going to start at the origin and I'm going to move -3 units. That means to the left 3 units. 1, 2, 3. This is where I'm at on the x-axis. The next thing I'm going to do is move +4 units. Positive means up, and I'm going to move 4 spots. 1, 2, 3, 4. There's my point. -3, 4. My last one, both are negative. What quadrant am I in? The x is negative, the y is negative. Quadrant 3. Very good. So I'm going to start at the origin, move 1 in the negative direction or to the left, and then y tells me I need to move down because it's negative 3 units. 1, 2, 3. And I have graphed my 3 points. There is a -1 and a -3 right there. Okay. So that is the coordinate plane or the Cartesian plane and being able to graph on it. Now let's take a look at solutions of equations. And this is really we're learning a staple that you will do throughout this course, substituting and evaluating. And that's what we're doing with this one. For solutions of an equation, what we're going to work with is we're going to work with a linear equation, and it is written in standard form. Ax plus by equals c. This is the standard form of a linear equation. And all that this is saying is that a is some number, b is some number, x and y are my ordered pair, the coordinate, and c is some number. And basically any equation, what it's saying is a times x plus b times y will equal c. A line is made up of nothing more than infinite number of coordinates or points. Think of pixels whenever you take a picture. It creates this picture, but all they are little dots. It's what the line is. The line is made up of an infinite number of those little points or coordinates. Not all coordinates in the coordinate plane are going to be on the line, or rather a solution to the linear equation. Only those that fall right on that line, and that's what we're going to look at. To see if an ordered pair is a solution to a linear equation, substitute the numeric values of the coordinate into the equation. So this is my equation, 3x plus 5y equals 28. And what I'm wanting to do is determine if the coordinates are solutions. Does this point fall on this line? Is it a solution? Does this point fall on this line? Is it a solution? So what we're going to do is we're going to evaluate this. Remember, my coordinate is x comma y. So what I have here is that x is 2 and y is 4. Right? X comma y. So I'm going to take and substitute or replace the value of x and the value of y. So what I end up with is 3 times 2 plus 5 times 4. And I'm going to see, does that equal 28? 3 times 2 is 6. 5 times 4 is 20. It doesn't look it. Looks like I have 26. So 26 does not equal 28. This is no or not a solution. It means that this point is not on the line. So let's look at the next one. Before we do that, if you want to pause the video and try it on your own, go ahead. Okay, so let's see if you guys got the same solution that I will end up getting. So again, this is x comma y, right? So I know that x is equal to 1 and y is equal to 5. I'm going to plug those in. So I'm going to say 3 times 1 plus 5 times 5, and what that should equal is 28. So 3 times 1 is 3, plus 5 times 5 is 25. Okay, that looks pretty good. I think this is a solution. So that is 28 equals 28. So yes, this is a solution to that equation, meaning this coordinate, this ordered pair, is on that line. It is a part of the line. And let's take a look at this graphically. Okay, graphically, I have graphed my line. This was the first ordered pair that we did, A. See, it's close to that line, but it's not on there. This was the last one we just did. It was a solution, and look, it is on the line. And there's my equation of the line, 3x plus 5y equals 28. All right, guys, good luck with your homework. Utilize this in your textbook. Critically think about what you're doing.